All right, welcome to day 68, MAP4C, and we've got lesson 7.3, which is on the regular payment of an annuity. The goal of the 3-minute review today is to solve problems involving the present value of an annuity, which was last class. So let's read the question. Ferd bought a used car and agreed to make $550 monthly payments over the next 6 years at 9% per year compounded monthly. What was the car worth if Ferd had the money up front? Well, in the last couple of days, we've met two formulas, and both of them are very, very similar and just a little bit nasty. This one was the amount formula, amount of an annuity, and I spelled annuity wrong there. No, I didn't. I'm good. And present value. Of an annuity. And more as we go on in this unit, we need to sort of make a decision on what formula to apply here, and this isn't so bad. So in this question, which one is it? I can see all the stuff here, all the stuff R and I and N. I can see all that business. That's 550 for regular payment. I is 9% compounded monthly, which is 0.0075, not quite a percent. And N is 6 years, 12 times a year, 72 payments, right? The question is, which formula do we use? Well, what do we want to find? Do we want to find the amount of the annuity at the end of the 6 years? Or do we want to find the amount of the annuity up front, the present value? So this idea is, if this is the 6 years of payments here, this is now, or present value, call it P, and this is the amount at the end, A. Ferd's making 6 years worth of payments in here, $550 a month. What was the car worth if Ferd had the money up front? Well, up front would be here, right? Present value. So we want to find the present value of those payments. That would be how much if Ferd had cash that he could pay for the car. Okay? Get back to my nice brown color here. And so where are you going to use this formula? This is a present value formula. 550 times 1 minus bracket 1 plus 0.0075, and I guess I could have squished that together. 72 payments all over 0.0075, and then you put that into a calculator. We'll help you out. We'll show you a couple examples today where we put stuff into a calculator, but you should get 30,512.27. That's a pretty expensive used car, I must say. But if he's paying $550 a month for 6 years, it better be, right? So he would pay that much up front. One would argue that probably he'd be paying less than that, because if he had all the money up front, he wouldn't have to worry about interest, and that's probably true. All right, so what are we doing? What are we up to today? Well, the name of the lesson is regular payment. So what we're going to do is we're going to end up finding R in these formulas. And it's a bit of a pain with all this stuff around. So what we'll do is we'll use some of our skills from the last couple of chapters to rearrange these formulas and get new ones. And that's what we're up to today. The expectations solve questions involving annuities where the regular payment is unknown. So the two annuity formulas that we have right now are these two. The one where A is the amount at the end, P is the present value, and if we want to find R, well, in this, we want to get rid of everything else and have R alone. Well, How are we going to do that? Well, the first step, I think, would be to get rid of the fractions. Well, how do I get rid of dividing by I? I multiply both sides by I. So the first step is to multiply both sides by I. And I don't know how you want to show that in your notes. Maybe even just like this. What did I do? I multiplied by I. What did I do? I multiplied by I. And then, of course, it cancels on the bottom, and that's why we did that, right? Well, what's the next step? Do I want to get rid of these brackets? No, let's not get rid of these brackets, because that is just a big, long mess that I want to get rid of, right? If I want to get R alone, all I have to do is get rid of this big red cloud. And I'm going to do that. How do I do that? Well, the operation between R and the big red cloud is multiply. So I'm going to do the opposite, which is divide. Divide both sides by big red cloud. Well, there we go. See, now this cancels out, and I'm left with R equals a formula for the regular payment, right? I'm going to put a box around that. We got to remember that one. That's going to be useful for us. So this is the regular payment when we're given the amount at the end. And we'll see the examples there. On contrast, the formula that we did this, it's almost exactly the same thing. You see what I'm going to do? I'm going to multiply by I. Multiply by I is the first step. And then instead of having AI, I'm going to have PI. And again, a big mess inside these square brackets. But to get R alone, all I have to do is get rid of the big square brackets on both sides by dividing. And then I get a new formula, right? Those will cancel. My new formula is R equals P times I, 1 minus 1 plus I to the exponent minus n. This is a very similar formula. Again, what is it finding? What does this formula find? It finds the regular payment when we are given the present value. Okay, so one of our tasks, of course, is to recognize when we should use one formula versus the other, and we will practice that. Andy, okay, well, it must be example time, I would say. Example time. It says, Ferd buys a used truck for, he's got a big collection of trucks now. A used truck for $12,500 makes regular monthly payments at 9% a year compounded monthly for 4 years. How much are his payments? So, which formula do we use, right? Most of the stuff is the same, the A and the I and the N and all that business. But the question is if we're using this one or are we using this one? And it matters because the stuff in the bottom is different, right? So what we ask ourselves then is this 12,500. This is the 4 years in here. This is the present value. This is the amount at the end. That 12,500, is it the amount now or is it the amount at the end? Well, if Ferd had the 12,500 bucks, he could walk that truck, right? That's the amount now. So we're going to use the present value formula. Right? Well, where's the present value formula? R equals PI over 1 minus 1 plus I to the exponent minus n. That's an I in there. Where R is we don't know. The present value of the truck was 12,500. I was 9% compounded monthly. Watch your decimals. And is 4 years, monthly payments, 48 payments. Dandy. Okay, now hopefully we can just plunk that into a calculator. It is a little nasty when we've got this big bracket on the bottom here, but we'll see it's not so bad. I is 0.0075, and then in brackets, a couple of brackets here, 1.0075 to the exponent negative 48. And I'm going to use my scientific calculator and go through this. On the top, it's, we're just multiplying two numbers there, so that should be okay. Times 0.0075 divided by bracket, that's this bracket, 1 minus this bracket, even though we don't really need it in this case, 1.0075 end bracket to the exponent. And in these old calculators, I got to put the number in first, then make it negative, and then end bracket. Big nasty number, but that's, this bracket is this big nasty number. I press equals, and is that a reasonable number? 31106. Well, this is his monthly payments, right? So his monthly payments short form there, payments, sorry, mess, that's okay, are $311.06. That's reasonable, right? Anybody with a truck payment would say that that's probably a reasonable payment. They've also asked us to use a TVM solver. So the TVM solver, you fire up the graphing calculators here. Remember, if it doesn't go right to your TVM solver like mine did, it's under apps, then finance, TVM solver, and now we put the particulars in here. Well, N was 48. The interest rate was just 9%. Remember, we don't do, the calculator will take care of all that business for I. The present value, the amount that the truck cost right now was $12,500. The payments per year, there were 12, the monthly payments. That'll switch automatically. And what do we want to find? We want to find the payment. And notice, it always does this change of sign thing. The idea is, if we owe the bank or borrow 12,000 bucks from the bank for the truck, then we pay off. So one's a plus, one's a minus. It's all even Steven for Ferd in his payment, but we can see it's the same thing. So I'm going to write those values in there. Actually, I'm not. You're going to. I'm just going to copy it and paste. And then we'll see that's exactly the same. And you may prefer the formula or you may prefer the TI-83. You got to know both. If you're not asked to do it one way or another, you get to choose. Okay? You get to choose if we don't say one way or the other. I'm going to pick up example 2 in part 2 of the video.